Alright, and welcome back. Now we're going to look at a bit of a practical demonstration using a multimeter and some resistors. We're going to connect it up on the breadboard. Here's our power supply coming in, positive up the top, negative down the bottom. And we're just going to have a look at a few values, like for example, checking out total resistance in a circuit, checking out the current, the total current, and then individual current going through each resistor. And also we're just going to have a look at the voltage, and we'll see that the voltage anywhere in a parallel circuit is all the same value. So, this lecture is titled Measuring Parallel Circuit Values, Voltage, Current, and Resistance. Okay, first what I want to show you here is, here's my multimeter leads, and you'll notice that I've got these white wires connected to them so that I can easily plug it into the breadboard rather than trying to hold them there myself. I've then got these leads plugged in over here. I've got the black in the COM connection and then the red in the milliamp connection, but at the moment I want to check resistance. So I'm going to put it into the volts and ohms connection over there. And before we start using our meter, let's make sure the meter works by shorting the two leads together, and we should be getting something less than an ohm, which we are. That's fine. Now you notice that did change a little bit. It's just because it's kind of hard to hold these together without giving a tiny bit of movement, but as long as we're getting less than an ohm, I'm quite happy that my leads are working perfectly fine. Okay, let's get rid of these for the moment. Now, remember, we've already gone through the breadboard, but just have a look. Remember, this bottom connection down here is all connected internally, all together. This top connection, all connected together. So it doesn't matter which hole I put something into, it's all going to be connected together up the top. At the moment, I don't want my power supply connected. I want to get rid of that because we first want to have a look at some resistor values. Now, to start off with, here is a 1K ohm resistor. It is a brown, black, red resistor. I'm going to connect that in like so. So bottom leg is now connected to any one of these holes, and the top is connected to all of these holes up there. Put the multimeter to resistance. It doesn't matter where I put my red and black leads. I could put it here and here. It will be measuring the resistance of that resistor. Remember, these resistors have a 5% tolerance. We're looking for 1000 ohms, and this is very, very, very close to that 1000. And just to show you, it doesn't matter where I put these. I can put that one over there, and I can put that one right there. It's still just got a direct connection to that resistor, so it really doesn't matter. So, we've got about 1000 ohms. Now, here's the interesting part. Let's get another 1000 ohm resistor and put it in parallel. So the bottom of this resistor connects to the bottom of that one, and the top of this resistor connects to the top of that one. If we were to do the calculation, either product over sum or the reciprocal method, we should get, on paper, exactly 500 ohms. In this case, you can see we're pretty much getting 500 ohms. It's just a little bit less because they each have a tolerance of 5%. So that's the last I'll say about tolerance, but just remember, if these values don't come up perfectly, it's because we have that tolerance. Okay, so every time we add a resistor in parallel, the total resistance, which is what our leads are measuring at the moment, the total resistance will come down. The reason for that is, the way a multimeter works, is coming out of this black lead, we've got electrons going out through here into our circuit. It comes across here, splits up, goes through these two resistors, joins back together, comes through the red lead. So if we have two resistors there, it is able to split up. But if we only have one, it is not able to split up. Therefore, there's less electrons getting through. If there's less electrons, it goes, oh, well, there must be more resistance there. So that's a very basic gist of how a multimeter is working when you're measuring resistance. Okay, now the other interesting thing with it, which I haven't mentioned yet, is if you're using exactly the same value of resistor in parallel, and you have two of them, the result you'll get for total resistance is going to be one of those divided by the number of resistors. So 1000 ohms divided by two resistors, we get 500 ohms. If we put another 1000 ohm resistor in there, because it's the same as the other two, it's going to be 1/3 of just one of these. So we're actually dividing by 3. So we should get 333.33 ohms. And as you can see, it's very close to that. What if we grab a fourth 1K ohm resistor? Put it in parallel with the rest? Well, it should be 1000 ohms divided by 4. And you can verify all this by doing the calculations if you like. Having a few troubles with that one. So it should be 250 ohms, and we're getting around about 250, which is really good. So the more resistors we put in parallel, the more these electrons are able to split up if they can split up more, kind of like the supermarket checkout, you're going to get more people through in the same amount of time. So there's more electrons getting through here. Now, if we were to remove any one of these, doesn't matter which one, we've now got 3, so we should be getting 333 ohms. Take out this one, we've got 2, we should be getting about 500 ohms. Take out this one, we've got 1, should be about 1000 ohms, and if we take this out, well, it's an open circuit. The resistance is so great between these two that we're getting OL. Okay, let's move on to using the power supply now. So let's put this to volts. I'm going to put my positive terminal to the top row and the negative terminal to the bottom row. Let's turn the power supply on over here. And I'm going to crank this thing up to 10 volts. No, very close, but too much. So if you like, you guys are welcome to do some calculations here. You can pause the video and do the calculations before I even measure it. And then you can verify that what I'm getting is actually what you're getting. So that's pretty much 10 volts. Okay, let's put one resistor in there. That's a 1000 ohm resistor. You can see we're still getting that 10 volts in it. It's just changing a tiny bit. Due to temperature variations within the power supply, you certainly might get a few little tiny fluctuations, which is fine. Doesn't matter where we measure, we'll still be getting basically that 10 volts, as you can see. How much current have we got going through that resistor? Well, this is where we have to, and this is very important. In fact, don't leave these connected like that when you set this to measure current. So what you need to do is disconnect it, then put this to measure current, and we're just dealing with very low current, so milliamps is fine. Put this over to milliamps. Now remember, in order to measure current through a circuit, you have to place this multimeter in series with what you're trying to measure. You can't put it straight across. If you do that, you're actually causing a short circuit across that, because a multimeter set to be an ammeter, so set to measure current, looks like a short circuit. So if we come along with these two, which is effectively a short circuit, you're going to be short-circuiting that, which means you're short-circuiting the power supply, and depending on your power supply, you could actually damage it. So we need to open it up. Then we place this in series. So that goes to the negative terminal, and this red one over here completes the circuit to the resistor like that. So the electrons are coming out of the negative across here into my black lead here, through the multimeter, into the multimeter circuitry, out of the multimeter red lead, out through here, back into my circuit, through the resistor and back here. So 10 volts here, that's 1000 ohms. We should be getting 10 milliamps, and we're getting 10 milliamps, which is fantastic. Now I'm going to leave that there. I'm going to put this in parallel. Let's see if anything changes with that resistor there. So this will be in parallel with that pre-existing resistor. And you can see we're still getting the same amount of current through this guy, even though we've added an extra resistor in circuit. Nothing changes about this guy just because that one has been added. However, what happens to total current? So let's disconnect the negative of the power supply from the bottom row, and let's measure the total current. So my black lead, this is my black lead right here, comes straight from this negative. My red lead is now going to complete the circuit to the bottom row. So just so you can see the two leads, there you go. Let's put this back. So electrons are coming out of my negative here, into the multimeter negative, out of the multimeter positive, down to this bottom row, and then goes across this bottom row through that resistor up to here. So there's our complete circuit. And you can see 10 milliamps. Now let's get that second 1000 ohm resistor. Let's put it in parallel. What's going to happen to total current? It goes up to 20 milliamps, because now those electrons come out here, they go through there, out this one, across there, then we can split up. This one's going to get 10, this one's going to get 10, so therefore the total is 20. What if we put 3 in parallel? Well, every single one we add in parallel, we're going to get another 10 milliamps, so it goes up to 30 milliamps. If we add another one in parallel, we're going to get another 10 milliamps, so we go up to 40 milliamps. And I could keep going like this forever, but I'm pretty sure that would be quite boring. Each one of these, in fact, we will measure each one of those. each one of these we'll find has 10 milliamps. So we'll check this guy right here. So 10 milliamps through, oh, okay, there we go. That goes there. 10 milliamps through that guy. What about this one? $10 milliamps through that one, and I won't do the rest, but you can see it's all going to be 10, no matter where we go. What about if we do different resistor values? So in this example, let's use a, I don't know, let's go 10,000 ohms. Struggling to put that one in the top. Let's try that again. 10,000 ohms, there we go. And let's measure the total resistance, total current, sorry. So negative my multimeter, straight to the negative of the power supply, and the positive is going to complete the circuit by going to this bottom row. So through here, through the multimeter, out of the multimeter, through to the circuit. So 10 volts, 10,000 ohms, 1 milliamp. And in fact, that one is spot on 1 milliamp, which is good. Alright, now we're going to add a 1K resistor. Remember, every one of these we add, we're going to get 10 milliamps. Here's a 1K resistor. So there's our 10. We now get 11 milliamps. What about if we added a 270 ohm resistor? So 270 is going to give us a lot of current. So that 1 milliamp is going to go up to 38.5 milliamps. Because this resistor value is so low, it's allowing through a lot of current. Okay, let's get rid of that power supply. I'm just going to turn that off because I don't need that anymore. So just to finish off, I just wanted to go back to resistance for a moment, just to show you that when you put resistors in parallel, the total resistance is always going to be less than even the lowest value of resistor. So here's a 10K resistor, a 1K resistor. Now let's get the resistance of that thing. There we go, so the black goes to the bottom, the red goes to the top, and I have a problem. Okay, there we go, I'm getting there. And so there's our 1K-ish. Now, if I was to put in a 270 ohm resistor, it has to be, the total resistance will be less than even the lowest resistor. So the total of these two is going to be less than 270 ohms. Which it is, 208. Let's get rid of the 1K, it'll go up to about 270. Okay, well let's show that with another one. Let's put a 150 ohm resistor in parallel. We know that any resistors in parallel, the total resistance will be less than even the lowest resistor. So this will come out as less than 150. And it's 96. Let's get rid of the 270, it'll go back to about 150. Well, let's put a 1K in parallel. It'll come out as less than 150. So it's 130. So, I mean, that's it. Hopefully this practical demonstration has helped cement in some things. But basically what we've found here is that when you put resistors in parallel, the total resistance, as shown by this, is going to be less. It's going to be less than even the lowest value of resistor. When you put resistors in parallel that are the same value, if we had a 1K and a 1K, we're going to get exactly half that. So you can kind of save yourself some calculation power there just by realizing, well, these are the same value of resistor. If the total resistance goes down, then it means the current goes up, and we measured that with these things. For every resistor you put in parallel, there's an extra current path, so the total current goes up. Alright, well that is it for that one. Thank you guys for watching, and get prepared for the next lecture.